Okay, all right. So handout one. So the section that first lesson that we'll be working today is about linear equation, solving linear equation and converting linear equation into echelon form. So these are the two main concepts that we'll be talking about. So before we begin the solving those questions, I just want to give you, very briefly, what is this linear algebra is all about? What are the key concepts that we'll be talking about in this course? So linear algebra is a branch of mathematics that deals with system of linear equation, matrices, vectors, and vector spaces. So these are the most important concept that we'll be dealing with. Okay. So linear algebra has application in science and engineering and economics and business and everywhere. In many fields, you will find the application of linear algebra. So the first section in your textbook in our course is linear, system of linear equation. I think you are already familiar with this idea of system of linear equation. Let us look at briefly what this linear equation means. Tell me, what is the meaning of linear?
The degree will remain 1.
Degree is
There will
one.
be no squares or cubes.
Exactly. If you look at this equation here, so the power of the variable is 1. But if you look at this, the power here is 2. So these equations are called linear. Okay, it's first degree equation. That's how we measure the degree of the equation. So the highest power of the variable determines the degree of the equation. For example, if you have x equals, let's say, x squared plus 2, this is your second degree function or second degree equation. If you have y equals x cubed plus 3x, then this is third degree equation, right? If you have, let's say, y equals, let's say you have xy plus 2x plus 1 equals 0. So what is the degree of this equation? Is it linear or no?
I think yes.
Why? Because the degree is 1?
Yeah,
Not,
maybe the reason.
no, the degree is 2 here, okay? Because these two variables are multiplied. So in that case, the degree is 2. So it is not linear. So if it is linear and if you draw the graph, let's say y equals 2x plus 1, this is linear. This one is linear. And if you look at this equation graphically, and if you draw the graph of this first degree equation, you always end up having a straight line. Okay, if you draw the graph of this, you will get a straight line. This one, you will get a straight line, but not this one. Okay, they are not linear, so you will not get a straight line if you draw the graph. Now, in this course, what we do is, like in high school, you just did, let's say, 2x plus 3y plus, let's say, 4z equals 0. Then, not usually when you have three variables, then I think most of the problems you were able to solve in high school. But since we are dealing with not only 3, not only 10, not only 100, sometimes million variables we need to deal. So this later xyz is not enough, right? So what we're going to do is, I'll write this way: x1, x2, x3. Okay, it means your x is x1, y, I replace that y by x2, z by x3. And if you want to draw the graph of this, then it will be x1, x2, x3. So that will be the axis. Whereas in high school, you have x, y, and z, right? That's what you did. It's just a switch from x, y, z to x1, x2, x3, because we'll be dealing with a lot of variable here, and that's what we're going to do. All right. Now, let us look at this example here. X1 minus 2x2 equals -1 minus x1. Okay, I want you to solve this equation. And if you solve this two equation, maybe the best way is to, cancel this one. And when you simplify this, you're going to get x2 equals to 2. And then substituting this value here, and you're going to get 3 and 2. So not a big deal. You can solve it easily. And that means your solution set is x1, x2 is basically 3 and 2, right? X1 is 3, x2 is 2. If you look at the equation graphically, if you draw the, let's say, graph of this, let us look at another example, okay? This equation, if you draw the graph of this equation, you will get this. It means these two lines intersect at a point, and we call it solution set. So the solution for this will be, can you calculate this quickly? X1 plus x2 equals 10, and negative x1 plus x2 equals 0. Can you tell me what is your x1 and x2?
Both are 5.
And x1 is also 5. All right, so this is the point 5 and 5. Right? Now, I want you to solve these two equations. Let's say x1 minus 2x2 equals -3, 2x1 minus 4x2 equals 8. Can you please solve this two equation and let me know what you get?
So it's 8.
So this is actually, I wanted to, yeah. If you solve it, then what do you get? Okay, no solution. If you solve it, you will notice that it's no solution. It's because if you draw the graph of this function, you see the slope will be the same. So they will be parallel actually. These two lines are parallel. Therefore, they do not intersect. And so there is no solution. Now let's try one more. Please solve this two equation now. These two equations. And let me know what you get. So you got 0 over 0. What does that mean? Okay, no solution. Not really. It means there are infinitely many solutions. If you draw these two lines, they will actually overlap. Okay, one line will overlap to the other. So that means they have infinitely many points of intersection. Therefore, the solution is infinitely many solutions in this case. Now, in this case, so the same method if you use, you multiply this by, let's say, -2, or maybe just multiplied by 2, for example, and you get how you solve it, I think, is 2x1 minus 2x2 equals -3. I mean 4x2 equals -6. And here you get 2x1 minus 4x2 equals 8. That's how you solve, I think. And when you change the sign, this cancel out, you got 0 equals -14. Is that possible? Which is not possible. It's impossible. Okay. In mathematics, 0 is not equal to -14. So whenever you get this 0 here and some other numbers there, it means there is no solution. But if you get 0 equals 0, which is true all the time, okay, 0 equals 0 is always true. In that case, you can say that the system has infinitely many solutions. Just keep that in mind. Now, what we noticed so far is that if we are given two equations, two or more equations for that matter, then one situation is it will, the line will intersect at one point. So you'll have one solution. Another situation is the line do not intersect. In this case, they do not intersect if they are parallel. In that case, we say no solution. But if the line overlaps, then we call it infinitely many solutions. Only three situations can exist. Okay, either one solution or infinitely many solution or no solution. Let me put this in a nice way. So the possibility is, if you are given a system of equation, the possibility is either it has a solution or it doesn't have, it has no solution. Okay, if it has solution, then two things can happen. One is one solution, another is many solutions. All right, that's the only possibility. Now there is a special word that we'll be using throughout the course. If you want to say that the system has solution, we call that the system is consistent. Okay, we'll be using this standard word, consistent. What it means is it has solution. It could have one solution or many solutions, but it has solution. If the system has no solution, we call it inconsistent. Okay, this is the main thing that we need to know in this section. Either the system is consistent or the system is inconsistent. Now, if the system is consistent, then the question will arise whether it has one solution or many solutions, and we can find that out. If it has no solution, then just done. Now, a couple of other definitions, by the way. Matrix. Oh, I think some of you have already done this matrix concept in your high school. I'm not sure how many of you have done, but anyway, can somebody tell me what is the matrix? What is matrix is all about? Well, if you put the numbers in such array, like in this kind of rectangular array, we call this matrix. Okay, the essential information of a linear system can be recorded compactly in a rectangular array called a matrix. Now, if you are given a system of equation, then two words you need to remember. One is called coefficient matrix, another is augmented matrix. And what's the difference between these two? Well, look at the system of equation here. X1 minus 2x2 plus x3 equal to 0, 2x2 minus 8x3 equals 8, negative 4x1 plus 5x2 plus 9x3 equals negative 9. Now, if you just write the, coefficient of the variable in the matrix form, we call this coefficient matrix. What it means is you are just putting the coefficient only, coefficient of the variable only in the matrix. So the coefficient of x1 is 1, and x2 is negative 2, and x3 is 1. Just put them together like in that form. And here x1 is 0. Okay, there is no x1 means 0, 2, negative 8, negative 4, 5, 9. Okay, so if you put this, just the coefficient matrix. Now, what is augmented matrix? Well, you put the coefficient and you include the constant term from the right hand side. Okay, 0, 8, 9. This part is the same thing, but you just include that constant term also, and we call it augmented matrix. Is there any question so far? So what we have discussed so far is a system of equation can be consistent or inconsistent. If it is consistent, then it can have one or many solutions. If it is inconsistent, then no solution. That's what we learn. And we also now know the meaning of coefficient matrix and augmented matrix. Now, matrix size. How do we determine the size of the matrix? Now look at this. This part is called row. Okay, this horizontal is called row and the vertical is called column of the matrix. So how many rows are there? This is your row 1, okay, and this is your row 2, row 3. In another word, there are 3 equations. Number of equations determine the rows. And 3 rows are there. And the column, how many column in this one? It's column number 1, column number 2, column number 3. So this matrix, the size of the matrix is always size of matrix, always represented by row times column. Always, row always comes first. That's how we determine. Okay, here is this tradition. Always follow the convention that if you want to write the size of the matrix, always row comes first. Okay, so this means this is 3 by 3 size. This is 3 by 3 size matrix. Now, what is the size of the augmented matrix in this case is there are 3 rows and 4 columns. Therefore, the size of the matrix is 3 by 4. That's how we determine the size. And elementary row operation, all of these things we'll discuss after a few minutes. Guys, I want you to try solving this example one just for fun. I know that you have done this kind of problem in your high school, but I want you to try just for fun, okay? Solve this just for fun. All right. I'll wait a few minutes and let me know what is your answer.
Do you mean write them?
Right, so thank you for giving me the answer here. So your answer is 29 x1 and x2 is 16, x3 is 3. And you can check your answers by yourself by plugging in the value in any one of these equations. And we notice that, we got true result, 0 equal to 0. So that means this answer must be correct. Now, we can solve this by using a matrix. Okay, so if you want to solve this by using matrix, solving by using matrix. So in this case, first you need to consider the augmented matrix, okay? Consider augmented matrix. And the augmented matrix here will be 1, -2, 1, 0, 2, 0, 2, -8, 8, -4, 5, 9, -9. Okay, now you can do the elementary row operation. Now let me go back what that means, okay? Okay, look at this system of equations. So this equation, if you solve this equation, what do you get? What is the answer? Okay, quickly solve this and let me know what is your answer. X equals to 2 and x1 equals to 3, right? If x2 is 2, then that will be x1 minus 4 equal minus 1, then x1 equals 3. Okay. All right. If you solve this equation, then what do you get? You get the same thing. X2 is 2 and x1 is 3. And here, this equation, it's x1 is 3 and x2 is 2. So these three equations have the same solution. Therefore, this system is called equivalent. Okay. Any system of equation that has the same solution is called equivalent system. Now, let us look at few things here. As a matter of fact, we can change this system, this system into this one easily. What I did here is I just added, let me say that this one is my equation 1 or row 1, and this is my equation 2 or row 2. What I did here is that equation, okay, let me write equation 1 and 2. We'll talk about the row later. This is your equation 1 and equation 2. What I did here is that equation 1 plus 2, if you do that, that's what you're going to get, right?
Yeah.
Okay, in equation, what we did here is that in equation, I copy the equation 1 as it is. In equation 2, I did 1 plus 2. So then if I do 1 plus 2, then this one cancel out. That's what we got. Now from here to here, what I did, what I did is I did nothing in the second equation. In the first equation, okay, in equation 1, what I did is I did equation 1 plus 2 equation 2. That's what I did. Does that make sense? Because I want to cancel this part. So how do I cancel? I multiply this by 2, and so that I will be able to cancel in equation 1. So equation 2 remains the same. Equation 1, that's what I did. So whenever we do this process, they are called row operation. If we change it into matrix. Now let's look at that. First, in order to solve this system using matrix, you may want to try, the goal is to make this is 0 and we want to make this 0. Okay, we need to follow certain step here. This number, just leave it. We call it pivot. We'll talk about that later. Now make everything 0 below that. And then this will be your pivot in the second one, and third one, this will be the pivot. So try to make everything 0 below that. That's what we call it changing into echelon form. We'll talk about that later, but at this moment, just try to, change this -4 into 0 by using the row operation. So if I want to make this 0, okay, make this 0, what we need to do is, in R3, this is my R3, this is your row 1, row 2, row 3. In R3, what you want to do is R3 plus 4R1, because we want to make this 0. If I do that, see what happens. I did nothing in R1, I just copy as it is. I did nothing in R2, I copy as it is. And what I did in R3 is R3 plus 4R1. So R3 is -4, 5, 9, -9, and 4R1. 4R1 will be 4, and 4 times -2 is -8, 4 and 0. And you add them together. So this guy will be 0. You'll get -3, you'll get 13, and you'll get -9. So I just want to copy this down here. -3, 13, -9. Oh, sorry. The first one is 0. The first one is 0, -3, 13, and -9. All right. So this first column, whatever we are supposed to do, we are done. Now, this is it is called pivot. Again, we'll talk about the meaning of pivot later. Now, anything below that, okay, in the second row, second column, this guy will be your leader, and anything below this, try to make it 0. You can make above also 0, but that's not important. Making below 0 is important. Now, I think if you want to make your life easy, what you want to do is maybe you can take this common. In R2, I want to do R2 divided by 2. So that it will change into 1, -2, 1, 0. This is 0, 1, -4, 4. Do you have to divide it? No. If you want to make life easy, yes. -9. If anything is common, then I just want to get rid of that in order to make life easy. Okay, now my pivot is this. All right, so anything below that pivot, below the leading term, I will make it 0. So in order to make this 0 in R3, what I want to do is, let me go all the way back here. Yes, Harmanjot, do you have any question?
Yeah, I just want to ask, if we have take the 2 common from the second row, then we also have to multiply the entire matrix with that one?
No, no. That's the beauty. You don't have to multiply. It
Okay.
automatically, because remember, in if you are given the, what we did here is that dividing by 2 is, you have an equation, let's say 2x 1 plus, let's say 4x2 plus 6x3 equals, let's say 10, for example. This equation, and if you divide everything by 2, you're going to get x1 plus 2x2 plus 3x3 equals 5. What I'm saying is that this one and this one are actually the same equation. Do you agree with me?
Yes, thank you.
Yeah, that's what we did. Yeah.
I have a question, sir.
Yes, go ahead.
So like R3 always has to be R3 plus 4R1 is a formula, or only that case we can apply?
Okay, remember, in the, our goal here, in order to solve this system using the matrix, is that this guy, we call it pivot or leading term for that column, and this guy is the leading term. Okay, in the second row, this second row, second column will be the leading term. Anything below that should be 0, and here is this. Anything below that is 0, but the good news is this is the last item, so we don't have to. So basically what we want to try is that we want to make this guy 0, which is already 0. That's a good news. We just want to make this 0. So this -4, how can you make it 0 using this, either R2 or R1? Usually we use the leading term. So whatever this pivot, is there, so using that pivot, we try to make this 0. So how can I make -4 0 with the help of 1? Well, I multiply that 1 by 4, and if I add, then I'm going to get 0. That's what I did. Okay, in R3, R1 do nothing, R2 do nothing. In R3, that's what we want to make 0. So what I did is R3 plus 4R1, and that makes this guy 0, this guy -3, and this will be 13, and this will be -9. And I see that there is this something common in that second row. So I just want to make life easy by taking that common out or by dividing. So that's what I got. Now remember, this is our pivot now. So anything below that, we need to make 0. So that means try to make this 0, okay? Make this 0 using the pivot.
But Professor, for
Yes.
the division step, what if it's a like coefficient matrix? So we don't have the right side, right? So
Oh, coefficient matrix, it will not help you to solve the system.
oh, okay.
Yeah. So we will deal with coefficient matrix in a different way. We will learn that in chapter 2. Don't worry right now.
Okay.
Now I'm going to go all the way here. Now tell me, how can I make this 0? Well, remember, always use this guy. This guy is R2, by the way. This is R1, this is R2, this is R3. So in R3, what I'm going to do here is I go from here to there. In R3,
R3 plus 3R2.
excellent. 3R2, yes. So what we did in R1, nothing. I just copy as it is. What we did in R2, nothing. Just copy as it is. What we did in R3, well, let's do it somewhere here. R3 plus 3R2. R3 is 0, -3, 13, and -9. And 3R2 is 0, 3, -12, and 12. Is that right? So this is your R3 and this is your 3R2. So now you add them. What do you get? 0, This will be 0. This will be 1. This will be 3. I just copy that down. So 0, 0, 1, 3. Okay. Now, this is called echelon form. By the way, this form is called echelon form. And we'll talk about the echelon form in a minute. Now, what it means is you can write this as x1 minus 2x2. Okay, this, remember, this one is x1, x2, x3. There are 3 values. So you can rewrite this matrix in the system of equation. You may want to change that. Suppose if you want to write this matrix in the system of equation, you will have x1 minus 2x2 plus x3 equal to 0. Another is 0x1 plus x2 minus 4x3 equal to 4. And this one will be x3 equal to 3. Okay, now substitute the value of x3 here and you get x2, and then substitute x3 and x2 there, you get the answer. Let's look at that. So x3 is this. So let's say this is my equation 1, equation 2, equation 3. Now substituting this value there, you're going to get x2 minus 4, x3 is 3 equals 4. What is your answer here? This gives you x2 equals to 16, right? 4 plus 12 is 16. Now we know x3 is 3, x2 is 16. Now you can substitute the value there. x1 minus 2, x2 is 16 plus x3 is 3 equals 0. So x1 equals 29. Okay, so we can use this matrix method. Right now, many of you might think that your high school method is easy, but if you need to deal with, let's say, 10 variable, 10 equation, 20 variable, 20 equation, 100 variable, 100 equation, then the high school method is not going to be fun. Okay, that will be really complicated, but this matrix will reduce the difficulty level quite significantly. And therefore, people in the computer engineer, computer programming, they use matrix a lot in order to solve, system of equations. Just keep that in mind. Okay. This is the main thing for this section. All right. But we'll take a break, and after the break, we just continue 1 or 2 problem in this, similar to this, just for fun, and then we move into section 2.1.2. All right, let's take 10-minute break. So example 2, a system of equation and its augmented matrix is given. Determine if the following system is consistent or inconsistent. So augmented matrix already given. Let me just copy as it is. Which is 0, 3, minus 6, 8, negative, 1, negative 2, 3, negative 1, 5, negative 7, 9, and 0. Okay. One warning, because the first one is 0. It cannot be 0. This is called pivot column. We'll talk about that later, but the pivot, the leader, cannot be 0. Okay, it must be non-zero element there. So how can we do that? Well, you may want to exchange that. Okay, R1 and R2. Let us exchange these two. So if you exchange, you're gonna get 1, -2, 3, -1, and another is 0, 3, -6, 8. And in third row, we did nothing, just copy as it is. Okay. Next, our goal is to make, you see, this one is your pivot. So anything below that pivot must be 0. So we need to make this guy 0. Okay, use a common sense now. This is an R3. Okay, in R3, what you want to do is R3 minus 5R1. Use the leading term, use this term in order to make this guy 0. That's what you may want to do. So R1 we did nothing, R2 we did nothing, we just copy as it is now. R1 1, -2, 3 and -1, just copy as it is. The second also copy as it is. And now third, what we did is, you can do this in your head, okay, at the later on, but right now let me just do the rough calculation here. R3 I did nothing. R3 is 5, -7, 9, 0, and minus 5 R1. So R1 is this, so you'll get -5, minus plus 10, minus 15, and plus 5. Right? Because this one is your R3, copy as it is, and this is your minus 5 R1. So you're gonna get that. If you add them, this guy will be 0, this will be 3, this will be a -6, and this will be 5. Just copy as now these values, 0, 3, -6, and 5. Right? Okay. Next, you see, this is your pivot in the second part, second row, and second column is your pivot there. Now you want to make this guy 0. Here you make this 0, and here make this 0. How do you do that? Just use
R3 minus R2.
exactly. Okay, so in R3, what you do is R3 minus R2. Notice that whatever operation we do, I wrote that first. Okay, I could have written this -5R1 plus R3. I could have written that, or I could have written R3 minus 5R1. They are the same thing. But remember, I write this intentionally because whatever the first row or column you see, that's where the operation is done. Okay, that's the convention that we'll be using. So if I write R3 first, that means I'm going to do the operation in R3. Now let me just do what is the remaining here. So the first row we did nothing, copy as it is. And the second row we did nothing, copy as it is. And the third row means this R3 minus R2, 0 minus 0 is 0, 3 minus 3 is 0, that minus that is 0, and 5 minus 8 is -3. Okay, now let us write down this, change it into a system of equation. Remember, this is your x1, x2, x3. Okay, they are the variables. So if I write this in the system again, I'm gonna get x1 minus 2x2 plus 3x3 equals -1. The second one will be 3x2 minus 6x3 equals 8. The third one will be 0 x3 equals -3, or you can say 0 equals -3. Is that possible?
No.
No.
Okay, this is impossible. If 0 equals -3, then the whole mathematics will collapse, right? So impossible. Now the question is, let's go back to the question. Our goal is to figure out whether the system is consistent, meaning whether the system will have solution or not. What is your answer here then?
No solution.
Inconsistent.
Excellent. Inconsistent, no solution.
Inconsistent.
Yes. Okay, that's the most important concept for this section, guys. So the system is inconsistent. This is the word we will be using, but it means no solution, right? This means no solution. So whenever you see that this is 0 and this is something, then there is no solution. For example, instead of this -3, 0 equals -3, if we get somehow 0 equals 0, for example, then what would your answer would be?
Infinitely many solutions.
Excellent. Okay, guys, so you grasp the idea. This is the most important thing. Now let's go to example 3. For what value of h will the following system be consistent? Okay, one thing I just want to mention, from now onwards, I'm not gonna go from here to there. I don't want to write the system of equation again, because once we have 0 and -3 there, it tells us that it is impossible. So I just want to stop there and say that the system is inconsistent, okay? But if you want to rewrite this in the system of equation, that's fine, no problem. Now, example 3, let us find for what value of h will the following system be consistent. Be consistent, okay? We need to figure out what is the value of h that will make the system consistent. Guys, I want you to try this just for fun, okay? Now, first, consider the augmented matrix. Which is 3, -9, and 4. -2, 6, and h. Either you may want to draw the line there, or you don't have to draw the line, because at the beginning, at the first, at least for a few classes, maybe I will draw a line to separate the coefficient and the constant term. Okay, but you don't have to. Okay, now I want you to change it into echelon form. This is called echelon form. So that means you try to make this guy 0. And yeah, go ahead. I'll wait. So to solve this system, what I did is, to make life easy, I divided this R1 by 3 so that I get 1, -3, 4/3, and I copy the second row as it is. And then my goal is to make this guy 0, this guy making this 0, to make this 0. What I did is R2 and R2 plus 2 R1, and R2 is -2, 6h, and 2R1 is 2, -6, 8/3. And then if you simplify, you're going to get that. Now, we already discussed earlier that if this 0 equals some number, its system will be inconsistent. Our goal is to make it consistent, okay? Make it consistent means if this is 0, then this must be 0. Then only the system will be consistent. If there is some number, then you don't have to worry. Anything is possible there. But because there is 0, then it must be, this part must be 0. So for the system to be consistent, x plus 8/3 must be 0, which means h equals 8 over 3. In that case, there are infinitely many solutions, by the way. Yes, so two of you raised the hand. Do you have any question?
Yes, I have a question. I was trying to solve different way, but I'm not sure. I did R2 equal R2
So in example 4, this is a word problem. So first of all, you need to change this English language into mathematical language. And once you change it into English into mathematics, then you will get, I think, 3 equation. And once you have the equation, you can write augmented matrix and you can solve the way we did before. So how do you change this into system of equation? It just requires common sense, right? So let us put the things in a nice way. So what I want to do is, there are a couple of things here. One is, suppose I need to create a mixture for dog food that has 8 grams of carbohydrate. So the first item is carbohydrate and 7 grams of protein. The second item is protein. And the third item is fat. So these are the 3 items there. And let me write down this. It says that write this as a system of equation and solve the system to find how many grams of each ingredient x1, x2, x3 is required. Let's say so I have 3 raw ingredient x1, x2, x3. So these are our variables. Okay, we need to create a mixture for dog food that has some gram of carbohydrate, some gram of protein, and some gram of fat. And then I have 3 raw ingredients, which is, I call it x1, x2, x3. Suppose that x1 has 1 gram of carbohydrate, x2 gram of protein, and 3 gram of fat per ounce. X2 has 2 gram of carbohydrate, 1 gram of protein, and 1 gram of fat. So x1 has how many gram of carbohydrate? 1. And then protein?
2,
2. And then the fat is 3.
3,
Okay. And x2 has how many carbohydrate?
2,
2,
1 and 1.
1 and 1. And this guy? And what is the total? 8 gram of carbohydrate, 7 gram of protein, and 11 gram fat. That is the total available. Okay, you see, once you write this in a systematic way, now you have the equation. So the system is linear equation becomes 1x1. I can simply write x1 plus 2x2 plus x3 equals 8. And this 2x1 plus x2 plus x3 equals 7. 3x1 plus x2 plus 2x3 equals 11. Right? Now consider augmented matrix. And after this, you go into breakout room, and then I'm going to send you to breakout room for the next maybe 5-10 minutes, and then you will solve it there with your friends, and then you will come back to the main room and you will report your answer, and then that's it for today. So that will be 1, 2, 3, 8. No, 1, 2, and 1. 1, 2, and 1, 8. 2, 1, 1, 7. 3, 1, 2, 11. Did I copy the right thing? 1, 2, 1, 8. 2, 1, 1, 7. 3, 1, 2, 11. Okay, yeah. So now, yeah, try this. Try to make this guy 0, this guy 0. Okay, and then, yeah, go for it. So I'm going to send you to a breakout room. So if you need to copy this, I think you have already copied this question. And now you're going to go to breakout room for a few minutes. In a small group, you can discuss with your friend, you can talk, okay? Help each other.